welcome back to this tactical intellectual channel. I really appreciate you guys for stopping by. Now on the agenda, we have a quasi reaction to present to you guys, and the topic will be Asia and the Pacific Islands migrations. We're dealing with migrations because I went over this topic a lot, but I want to convey and present facts and have everything airtight when I present things. So the content creator above the clouds, I will be reacting or doing a quasi reaction to his video presentations, his excellent work. So let's begin.
But to understand these Neolithic migrations into the Americas, we first have to understand when the Americas was first populated and by whom. To understand that, we have to go back to Africa, the Levant, and the very beginning of the Paleolithic out of Africa migrations.
This is the Wadi Gadoon, one of the biggest ancient river valleys in all of Arabia, perhaps. It's probably half a mile to the other side. It's dry now, but 100,000 years ago, this thing was full of water. All of Arabia was green, for that matter. It was covered in savannas and lakes, and you have this vast network of river valleys that run through this plateau.
He began to explore the hilltops above the ancient riverbed. And here, he found a field of flaked rocks.
So, this is the stuff I've been looking for all those years along the coast. This is called chert or flint, and it's the raw material that was essential to make the stone tools throughout prehistory. And the site like this is literally covered in a carpet of this material. Prehistoric tool makers would come to a site like this, they would bang away, make their stone tools, leave the refuse behind, and then go off down into the valleys where the water was. So this is a prehistoric workshop.
It was unmistakable. People had passed through here and hung around long enough to make thousands of tools. But who and when? The stones told him all he needed to know.
That is gorgeous. That is a classic Nubian point. This is the tool that was made by the first people that left Africa.
Nubian points came from a part of Africa now in modern-day Egypt. They were made about 100,000 years ago. If the same tools can be found in Oman, it suggests people were on the Arabian Peninsula at the same time. 100,000 years ago.
We're not looking at something that looks like it may have a similarity to an African technology. We're looking at the identical African technology.
All right, so let's move up a little bit to...
For the first peoples, the way into Asia was open. From Arabia, they migrated eastward into Central Asia, northern India, and beyond. They would have followed a network of rivers, natural corridors through the continent. Southeast Asia, 63,000 years ago. A band of hunter-gatherers on the lookout for food. They're newcomers here, migrants from Africa, at the edge of the known world. People in the tropics tend not to live in caves. There are too many poisonous predators. They use them as a shelter to escape the rain. But for one young woman, this cave will be her final resting place. Her people left Africa and migrated 4,000 miles eastward, following game, looking for new sources of food.
South Asia, Australia, and Melanesia have the special distinction of being the earliest locations on Earth settled by modern humans leaving Africa. Some of these groups of early Africans arriving in these regions as early as 100,000 years ago. These early Africans would have arrived in a very different looking South Asia and Austro-Melanesia. During the Paleolithic out-of-Africa migrations, instead of these regions consisting of several different islands, they were in fact two large conjoined land masses, known respectively as Sundaland and Sahul. Sundaland was connected to mainland Southeast Asia and contained modern countries like Bali, Borneo, Java, and Indonesia, where Sahul consisted of Australia and what is now the islands of Papua New Guinea. Even the islands of the Philippines were one landmass connected to Borneo. These early Africans that would make Sundaland and Sahul their new homes would go on to have one of the oldest continuous population histories outside of sub-Saharan Africa. And one of the things that is immediately noticeable about many of these modern populations in these areas is many of them still look black. Many of these populations, unlike many other regions around the world, have retained their ancestral sub-Saharan African phenotype. Outside of Africa, they're the only populations to retain this skeletal morphology. And it's not just their black skin color, but their actual cranial morphology. Remember, these traits are genetically inherited. Thus, they still have many of the traits of their African ancestors, such as pronounced amounts of alveolar prognathism, that wider nasal aperture, and that distinctive African long-headed dachycephalic skull shape. There are several different major groups that make up these regions. One is the Negritos, a broad term that encompasses many of the native short-statured black peoples that are descended from the original African inhabitants of Sundaland. Some of these groups include the Onge, or the Andaman Islanders, the Aeta, and the Batak. These dark-skinned groups are often referred to as Orang Asli, or original peoples, by the lighter-skinned Mongoloid peoples that migrated into these regions during the late Neolithic. These groups also include indigenous Australians, referred to in modern day as Australian Aborigines, as well as the various groups of Papua New Guinea, such as the people of Bougainville, or the native Melanesian peoples of the Solomon Islands. These people are the descendants of the original African inhabitants of Sundaland and Sahul over 80,000 years ago. It's often been said, quite inaccurately, that the appearance and skin color of these South Asians and Australo-Melanesians is a coincidence, a fluke. They in fact look black on accident, a process of convergent evolution. This is a complete lie. These people have this skin color and this phenotype because of their ancestors. It is the skin color and phenotype of their ancestors from Africa. These groups arrived there with that skin color and that phenotype and have simply retained it over the millennia. We in fact know this because these people share several genetic variants, or SNPs, that are identical by descent with Africans, meaning that several portions of their DNA are the exact same as their African ancestors and their relatives in modern Africa. But before we touch on that, what exactly is an SNP?
All right, so it's going to get a little heavy. Take your notebooks out, pen and paper. Get ready to screenshot on your phone or your PC, or just retain it in your memory banks.
And what exactly makes groups of people related? Well, the first thing that should be understood is that all human beings, no matter where they're from, are 99.9% genetically identical. All human beings are from Africa and have black African ancestors. These were fully modern humans with speech and art and invention and technology that left the African continent and populated other regions of Afro-Eurasia. These were not hominids or pre-humans, but modern black human beings. This is why all human beings have nearly identical DNA, being 99.9% the same. That 0.1% accounts for all the differences we see amongst modern groups of people. These differences are caused by mutations that are known as SNPs or SNPs. These SNPs, or variations in DNA, account for differences like eye color or skin color or height or hair texture or certain diseases. Thus, we can say certain groups are related by their shared SNPs or genetic variants, as groups with certain mutations have a common set of ancestors. So, what causes these SNPs or SNPs? And what does it stand for? SNP stands for single nucleotide polymorphism. Single, of course, means one, and nucleotides are the building blocks of your DNA. And polymorphism simply means change or mutation. To start off, your DNA is made up of 4 nucleotides, known as adenine, cytosine, guanine, and thymine. These nucleotides attach to each other to forge chemical bonds known as base pairs, which connect 2 DNA strands. These base pairs are labeled as A, C, G, and T. And these base pairs serve as the instructions for coding proteins to make up your body. As a cell copies its DNA before dividing, it occasionally makes typos. So sometimes a single base pair will be substituted, deleted, or duplicated. And these changes or mutations in base pairs can have no effects or major effects. And these mutations, or single nucleotide polymorphisms, account for the major changes we see amongst human populations. These mutations, or SNPs, are then subsequently passed down to subsequent generations. Thus, we can trace the origin of populations by their shared polymorphisms, or SNPs. For example, let's take a look at the Y chromosome. All Y chromosomes originate in Western Central Africa. It's in these regions we find Y chromosomal Adam, the ancestor or father of all men and paternal lines that walk the earth. It's here in West Africa we find A00, the beginning of all paternal lines of Africa and of all paternal lines of the human race. To quote Fernando L. et al., we report the discovery of an African American Y chromosome that carries the ancestral state of all SNPs that define the basal portion of the Y chromosome phylogenetic tree. We sequenced 240 kb of this chromosome to identify private derived mutations on this lineage, which we named A00. We then estimated the time for the most recent common ancestor of the Y tree as 338,000 years ago. This is the beginning of the Y phylogenetic tree. All Y chromosomes are versions of this original Y chromosome. The only difference is they've acquired SNPs or mutations that allow us to tell them apart from the original Y chromosome. So a BY chromosome is simply an AY chromosome with additional SNPs or mutations that let us distinguish it from that original AY chromosome. Same thing with a CTY lineage. It's a version of a BT lineage with additional SNPs, namely mutation M168 and M294. Thus, all letters of the Y phylogenetic tree are simply a version of the preceding Y chromosome, just with additional SNPs or mutations. So, while we typically label the Y phylogenetic tree A through R, if we wanted, we could label it A0 through A17, because in fact, all Y chromosomes are a version of that original A with simple additional SNPs or single nucleotide polymorphisms. The first 6 mutations of the Y chromosome tree occur in Africa, namely A, B, C, D, E, and F. All of these Y chromosomes have an African origin. Then Africans carrying one branch of haplogroup D and haplogroup CF will leave out the African continent and subsequently populate the rest of the world. And it's important to know the people that left Africa were still very much African, and they very much looked African for thousands and thousands of years, and in some cases they still do look African. I think people have this idea in their head that once people left Africa, they stopped being related to black people and people in Africa, which is not the case at all. As people migrated into new regions, they simply accumulated different mutations. But I can't state this enough. The mutations that happen inside of Africa are no different than the mutations that happen outside of Africa. They're all simple mutations on the exact same original African genome. So, as I said, we can see how certain populations are related by their shared SNPs, or SNPs. For example, sickle cell anemia is caused by a very specific SNP. This switch, or nucleotide polymorphism, causes a mutation in the protein that makes the red blood cells, causing many of the patient's blood cells to take a rigid sickle shape. And of course, these alleles, or SNPs, spread out in large numbers during the age of the Green Sahara. Thus, all peoples with sickle cell, whether they live in Africa or Eurasia, have a shared West African ancestry. So, while a mutation like sickle cell causes changes we can see on the inside of the body, some of these mutations, or SNPs, cause changes we can see on the outside of the body.
Alright, so Palito, Stankaisian, Caucasian, white people, whatever you want to call yourselves, and then those who are adjacent to them or uphold the narrative that they put out there. Listen up carefully.
Such as skin color. So, for example, the SNP that causes light skin is only about 20,000 years old, and that mutation won't become widespread into regions like Europe till the Indo-European migration around 5,000 years ago. Whereas the mutation for light skin in East Asians is a little different, being only about 6 to 12,000 years old. So both of the typical light skin phenotypes we usually associate with both Europeans and East Asians are very new and caused by very recent mutations or polymorphisms and subsequent migrations of peoples from colder regions. For example, the mutation that causes depigmentation in East Asians is located on a completely different part of the genome than Europeans, namely the OCA2 gene on the 15th chromosome. Remember, SNPs are simply mutations in base pairs, made up of adenine, cytosine, guanine, and thymine. These base pairs are read off in triplets known as codons, and of course changes in these instructions in these base pairs of A, C, G, and T, and how they're read, causes changes that we can sometimes visibly see in people. In this case, it causes changes in skin color. To quote Murray, two OCA2 polymorphisms, RS1800414 and RS746533330, have been associated with pigmentation in East Asians. We explored the distribution of these markers in a panel of samples from populations around the world. The derived allele of RS1800414 has high frequencies in a broad East Asian region, whereas the derived allele of RS746533330 is primarily restricted to northern East Asia. The haplotype analysis suggests that the haplotypes carrying the derived alleles for each polymorphism arose independently from the same ancestral haplotype. Using the markers RS7170451 and so on to define the haplotype block, our results indicate that from the ancestral haplotype AAGAGCAGGTT, or adenine, adenine, guanine, adenine, guanine, cytosine, adenine, guanine, guanine, thymine, thymine, a non-synonymous mutation at RS1800414 originated the haplotype AGGAGCAGGTT, or adenine, guanine, guanine, adenine, guanine, cytosine, adenine, guanine, guanine, thymine, thymine. And another non-synonymous mutation independently originated the haplotype AAGAGCAAGTT, or adenine, adenine, guanine, adenine, guanine, cytosine, adenine, adenine, guanine, thymine, thymine. Both derived haplotypes then increased in frequency in different regions of East Asia. The haplotype AGG-AGCA-GGTT is now the most common haplotype in a broad region of East Asia, whereas the haplotype AAGAGCAAGTT has become the most prevalent in northern East Asia. Several lines of evidence indicate that this increase in frequency may have been the result of positive selection favoring light skin in high latitude regions. Both the derived alleles are non-synonymous variants predicted to have a functional effect, and both have been associated with lighter skin pigmentation in East Asian populations. In addition, several studies have identified signatures of positive selection in the OCA2 region in genome-wide scans in East Asian populations. The geographic distribution of the variant strongly suggests that these two mutations arose after the separation of European and East Asian populations. This is supported by a recent study that dated the derived G allele of the OCA2 RS1800414 polymorphism to 10,000 years ago. To our knowledge, there has been no attempt to date the polymorphism RS7465330. We use the dense genome-wide SMP data available for the HGDP CEPH panel to estimate the ages of the derived alleles at RS1800414 and RS7465330 in East Asian populations. We used a method that relies on the decay of haplotype sharing of the ancestral genomic segments on which the derived mutations occurred. Under these conditions, and assuming a generation time of 29 years, we estimated the age of the derived allele at RS7465330 to be 6,835 years old, with a 95% confidence interval between 1,070 and 12,798 years ago. The estimated age of the derived allele at RS1800414 is quite similar, at 6,397,000 years ago, with a 95% confidence interval of 1,183,000 years ago and 11,446,000 years ago. Recent ancient DNA studies, which have characterized dense genomic data in Eurasian individuals spanning a broad archaeological period, e.g. from hunter-gatherers to individuals living in the Bronze Age, have provided important information about the temporal distribution of genetic markers associated with pigmentation variation in Europe, and have strengthened the case for selection operating in the pigmentation-related genes in this region. Similar studies in East Asia have the potential to clarify the major events that have shaped the interesting distribution of the two non-synonymous variants of the OCA2 gene in this vast area. In this respect, it will be important to consider not only potential selective effects, but also the major population movements that have taken place in this region during the past 15,000 years.
All right, so he mentioned the OCA2 gene. That stands for oculocutaneous albinism. Oculo deals with the eyes, cutaneous, the skin, and then albinism, of course, you know what that is. So, it all deals with the deep pigmentation of your eyes, skin, and hair.
And this brings us back to the peoples of South Asia and Australo-Melanesia. As I said earlier, these people are unique amongst populations living outside of Africa, as they've retained their ancestral African phenotype and skin color. And as I said, this is not due to coincidence or convergent evolution, but their shared African ancestry with their relatives in the African continent, having several shared SNPs or genetic variants that are identical by descent with Africans, namely mutations on several genes.
Hold up, let me go back right quick, because I've been looking at this the YouTuber Adonis in the UK, and it's funny because like the UK Africans, the first generation or the fresh off the boat Africans, I guess immigrate or move to the UK, they take on a UK mentality, something that the Africans on the continent don't really display. And then the Africans in Canada and the US, they don't display this type of attitude either. But, say this Papua New Guinean guy right here, say if he was walking around London and then one of the UK Africans be like, where you from, blood? In it, or whatever. They would question this dude and be like, would they say he doesn't know where he's from? Bro, he's been out at the continent of Africa for millennia, millennia on top of millennia. So all he knows is the Pacific Islands and the Asian areas. So, but he looks straight Nigerian, or like he's from Senegal or wherever. Pick one of the 54, but he looks like that. But you shouldn't question him about his lineage, because he's valid. He's rooted in his region. So,
or genetic variants that are identical by descent with Africans, namely mutations on several genes, such as DDB1 on the 11th chromosome, OCA2 on the 15th chromosome, and TMIM138 on the 19th chromosome. These are only a few of the shared SNPs between Australo-Melanesians and African populations. These specific mutations only being shared by these two populations. To put it in layman's terms, they look African because they're from Africa, even though they don't reside there currently. For example, this is me as a little kid, and my sister, and my dad, and my cousin. And these are Papuans, and Aborigines, and Melanesians. Why do we all look alike? Why do we all look like family? Why do we all look like we're related? That's because we all have the same genetic variants. We all have the exact same ancestral African SNPs dictating our phenotype. To quote Crawford, individuals from South Asia and Australo-Melanesia share variants associated with dark pigmentation at MFSD12, DDB1, TMIM138, OCA2, and HERT2 that are identical by descent from Africans. This raises the possibility that other phenotypes shared between Africans and some South Asian and Australo-Melanesian populations may also be due to genetic variants identical by descent from African populations, rather than convergent evolution. This observation is consistent with a proposed southern migration route out of Africa 80,000 years ago. Alternatively, it is possible that light and dark pigmentation alleles segregated in a single African source population, and that alleles associated with dark pigmentation were maintained outside of Africa only in the South Asian and Australo-Melanesian populations, due to selection. So, as we can see, the appearance of these populations is not from coincidence, but their actual African ancestry and shared African genetics. So now that we know that, when exactly did people first arrive in Sundaland and Sahul? When did the African ancestors of the Australo-Melanesians first arrive? Well, the three groups that left out of Africa carried three distinct Y chromosomes, as we know, D, C, and F. The DY chromosome has its origin in Western Africa. There is one place in Africa you can find the D haplogroup, and that is here, its place of origin, West Africa, Nigeria. To quote Haber et al., here we reinvestigate a rare deep-rooting African Y chromosomal lineage by sequencing the whole genomes of 3 Nigerian men described in 2003 as carrying haplogroup DEY chromosomes, and analyzing them in the context of a calibrated worldwide Y chromosomal phylogeny. We confirm that these 3 chromosomes do represent a deep-rooting DE lineage, branching close to the DE bifurcation, but place them on the D branch as an outgroup to all other known D chromosomes, and designate the new lineage D0. The most favored model involves an origin of the DE lineage within Africa, and D0 and E remaining there, and migration out of the 3 lineages C, D, and FT that now form the vast majority of non-African Y chromosomes. The exit took place between 50,300 and 81,000 years ago, and most likely between 50,300 and 59,400 years ago. This work resolves a long-running debate about Y chromosomal out-of-Africa, back-to-Africa migrations, and provides insight into the out-of-Africa expansion more generally. D is the dominant Y chromosome of the Onge and the Andaman Islanders, indicating their ancestors had a Western Central African origin. These early West African migrants also were the first people to populate regions like Japan. These early West African populations, bearing that DY chromosome, also were the first to populate the regions of Tibet, where the DY chromosome still dominates till this day.
All right, so you heard what he just said, that these people originally populated Japan. In my Ainu video, the video that I reacted to inside my video presentation, that's confusing, I know, but it mentioned the C and D haplogroups being there, and that the earliest occupants or the first original people of that area was like D and C haplogroups, melanated people.
To quote Mandal, the Andamanese stand out in our dataset because of their haplogroup D, which in India has been reported only in the Andaman Islands and is present in all of the 5 individuals we sequenced. This haplogroup is especially interesting as it has a deep genealogy, sharing a 4,000-year more recent ancestry with the African haplogroup E than all other haplogroups found in the out of Africa populations. This relationship with African populations has been a basis for postulating a distinct early out of Africa migration, differentiated from the later and more widespread Asian expansion. This proposal is in stark contrast to findings from the autosomal data, where the Andamanese showed a common ancestry with other Asian populations without a trace of contribution from a putative early out of Africa population. In addition, this haplogroup has been found at high frequency in Japan and in Tibet. We found that this haplogroup in the Andamanese has a deep substructure, which is a much higher ratio than for other Indian populations. This suggests that the Andamanese Y chromosomes have had a long-lasting separation from the other populations examined, and that male gene flow into the Andaman Islands has been limited. As this haplogroup is found at high frequencies in Japanese individuals from Tokyo, from the 1000 Genomes Project, it is possible to analyze the divergence times between the two populations for both the haplogroup DY chromosomes and the autosomes. The divergence time between Andamanese and Japanese haplogroup DY chromosomes is 53,000 years ago, while the divergence time between haplogroup D and O chromosomes is 77.3 thousand years ago. In contrast, the autosomal divergence time is 52,000 years between Andamanese and East Asians. This possible discrepancy between Y chromosomes, divergence between D and O haplogroups, and autosomal divergence between Andamanese and East Asians could potentially be explained by 2 different hypotheses.
All right, so the key thing to look out for is divergence time. Now, it doesn't matter if you're pro-black, pan-African, or if you just hate black folks in general, if you're Asian or European, the modern day definition of those people, divergence time, that's key right there. And mainly I'm speaking to the pan-African people that want to just, I guess, discount divergence times, that see melanated people as all the same, no matter what. Now, divergence time, that's key. Like, you got to go back millennia on top of millennia, the Holocene period. And then don't discount these early migrations, man. And the divergence time is the time it took before these populations became distinct from the original population. Basically, the population that stayed within Africa, and then the ones that left, they became different. I mean, in my opinion, I think it's out of respect to those melanated populations that are outside of Africa, instead of just calling them Africans and then calling, the people that came later than these people that, basically the people that entered into the area first and they're actually still here. I think they have first dibs on being the representatives of that country. You know, I know they're outnumbered now, but instead of calling the people that first entered into the land Africans and putting that other status on them, just call them the first Japanese or the first, Australians, or the first Americans, first Europeans. The people that's like pan-Africanists, they want to say, hey, these are Africans and they're different than, you're giving too much respect to the second or late coming populations. That's all I'm saying right there.
It could be caused by two different settlements. People with haplogroup D first populated Asia, including the more external localities like the Andaman Islands and Japan. Later in Japan, this haplogroup was partially replaced by haplogroup O individuals. According to this model, haplogroup D is more frequent in the two extremes of the archipelago as a consequence of this later replacement. Or B, if a single main out of Africa event happened, haplogroup D, along with other haplogroups in the other out of Africa populations, i.e., C and macrohaplogroup F, were already present in the initial out of Africa population, but later haplogroup D was lost from other populations by random drift, except in the Andaman Islands, Japan, and Tibet. If the first hypothesis were true, even if the genomes of Japanese O and Japanese D had homogenized, we would expect the Andamanese and Japanese D to share more derived autosomal alleles with each other than with other East Asian populations. We found that this is not the case. In fact, as seen from the autosomes, the Andamanese are an outgroup to East Asian populations, diverging in a trichotomy with East Asians and Indians. Another important Y chromosome of these early out of Africa populations is haplogroup C. This is the dominant Y chromosome of the indigenous Australian Aborigines and also has its origin in Africa as well. To quote Halast, here we show that phylogenetic analysis of haplogroup C, D, and FT sequences, including very rare deep-rooting lineages, together with phylogeographic analysis of ancient and present-day non-African Y chromosomes, all point to East-Southeast Asia as the origin 50,000 to 55,000 years ago of all known surviving non-African male lineages, apart from recent migrants. There is one region of the genome with the potential to inform about these events in a unique way, the Y chromosome. This is because its male-specific portion provides haplotypes from which a detailed, calibrated phylogenetic tree can be created. Several such trees have been constructed independently and are all consistent in being dominated by a massive expansion of non-African Y lineages during the key interval of 50,000 to 60,000 years ago, starting from a single haplogroup designated CT. Taking into account a rare African D0 lineage and the time frame summarized above, we have argued that the initial splits within CT are likely to have occurred inside of Africa before the exit, and that three lineages, C, D, and FT, were carried out by the ancestors of present-day non-Africans. Each of these three lineages subsequently expanded, C and D moderately and FT massively. It's important to remember that during the Paleolithic, both Australia and Papua New Guinea are one landmass known as Sahul. These populations are some of the oldest on the planet, and in fact, modern Papua New Guineans still have up to 2% of an even earlier wave of human migration from Africa, dating back over 100,000 years ago. To quote Pagani, we find a genetic signature in present-day Papuans that suggests that at least 2% of their genome originates from an early and largely extinct expansion of anatomically modern humans out of Africa. Together with evidence from the Western Asian fossil record, an admixture between anatomically modern humans and Neanderthals predating the main Eurasian expansion, our results contribute to the mounting evidence for the presence of anatomically modern humans out of Africa earlier than 75,000 years ago. The paths taken by anatomically modern humans out of Africa have been the subject of considerable debate over the past 2 decades. Fossil and archaeological evidence and craniometric studies of African and Asian populations demonstrate that Homo sapiens were present outside of Africa 120,000 to 70,000 years ago. However, this colonization has been viewed as a failed expansion out of Africa, since genetic analysis of living populations have been consistent with a single out-of-Africa migration followed by serial founder events. In conclusion, our results suggest that while the genomes of modern Papuans derive primarily from the main expansion of modern humans out of Africa, we estimate that at least 2% of their genome sequence reflects an earlier otherwise extinct dispersal. The inferred date of the early out of Africa split time is 120,000 years ago and is consistent with fossil and archaeological evidence for an early expansion of Homo sapiens from Africa.
Man, you know what's crazy? I was just thinking about this. Like, I'm a fan of comic books, and I like X-Men, Spider-Man the most. Now, with X-Men, there's a character named Bishop. He's from the future, but he's an Australian Aboriginal or original Australian guy. And every time when I like read YouTube comments on a video that pertains to this character, it's always like some white guy or Asian guy. They always be like, man, why they made Bishop black? He ain't black, he's from Australia. And it's just like, you know, people that's from the original Australians, the melanated Australians, they never ever bring this stuff up. You know, they know we genetically similar, you know. So I mean, it's just the cultural and tribal affiliations that's different. But the genetics, I guess they want him to look like a modern day white Australian or something, or close to it. And then even with a character that is Filipino, it's another character that's Brazilian, and they try to, you know, whitewash him. But you know, I digress. You know, all you gotta do is just look at this screen that I paused the video on, that I will resume. But it's just something that didn't really have anything to do with anything. It's just something that came to my mind while going over this subject.
These early African migrants in South Asia would be the first modern humans to make a significant sea voyage, becoming the first peoples of Sahul, bringing with them their culture, technology, and religious practices from their native homeland of Africa.
Southeastern Australia, 42,000 years ago. A man is buried by a lakeside. He's a clan chief or something similar. Important enough to be buried with ceremony. He's known to archaeologists as Mungo Man. Here, at the very ends of the earth, is some of the earliest evidence of our yearning for spirituality. Mungo Man was discovered in 1974 by geologist Jim Bowler.
This is an amazing view of the landscape. It's wonderful to be back here.
One summer's day in 1974, Bowler was riding his bike at Lake Mungo when he saw something unusual eroding out of the dune.
I spotted a tip of white bone exposed on the surface of the sand, and it was over near here, just the top of cranium coming out of the sand. And when I brushed away the lower part, the jaw was there. So immediately I recognized I was standing on the burial of a human remains.
The bones were 42,000 years old, twice as old as remains found anywhere else in Australia. What was most striking was they'd been stained with a natural pigment, ochre.
There's that ochre again. It's very pertinent to this subject here, as you will see in later video presentations on this platform.
There's no ochre within 100 kilometres or more from here. The ochre had to be brought in. It had to be prepared. All that preparation for the moment of burial, that went on for days.
Humans had already been using ochre for thousands of years in Africa as a way to decorate their bodies or treat their hides. But here, it was an integral part of an elaborate ritual ceremony.
He was laid out as the way we would lay out my own father in his funeral coffin, and he was then ceremonially farewelled. It was not just the mourning of death. It was even perhaps something of a celebration of life, really.
Mungo Man is not the only body Jim Bowler has found by the lakeside. A quarter of a mile away, he discovered fragments of a female skeleton that became known as Mungo Lady.
This is the sort of horizon in which I found the bones of Mungo Lady.
When anthropologists put together all the fragments from Mungo Lady, they had evidence of another funeral ritual from the same period, 42,000 years ago. Mungo Lady's bones had been burnt, perhaps to make them more brittle. Then they were broken into tiny pieces. Lake Mungo was clearly a home for a community of people with a rich, complex culture. But who were these people living at the edge of the world? Where did they come from? When did they arrive? How did they get here?
All right, so pay attention thoroughly to this, these next factuals, and jot down in your notebook if you want to.
Lake Mungo is tucked away in the southeast of the country, an isolated corner in the world's most isolated continent. It's a mystery how people ever reached Mungo, because there's so little archaeological evidence from that period anywhere in Australia. But there are clues to be found in DNA. At the start of the 20th century, British anthropologist Alfred Haddon went to Australia to record the customs of the indigenous people and collect samples of their hair. His collection remained in a museum, gathering dust, until a Danish geneticist, Eske Willerslev, got to analyze the samples.
The beauty about hair is that it's not porous like bone and teeth. So it means that all contamination from all people who have handled it over the years is all sitting on the outside of the hair. So you can basically just put it into bleach and then get rid of the contamination, and the DNA remaining is the one from the individual himself. This hair collection from Cambridge has probably many times people have asked themselves, what should we use this hair for? And then 100 years later, I mean, this turns out to be actually a piece of gold for a geneticist.
The hair sample came from a man in the outback of Western Australia, which had barely been visited by Europeans at that time. So the DNA was pure Aborigine. This was the first time anyone had sequenced an Aboriginal genome. From this one sample, it was possible to unlock the ancient history of a people.
Archaeology tells us that humans were present in Australia at least 40,000 years ago. The question is, of course, who were these people? How were they related to present-day Aboriginal Australians or to other peoples in the world, for that matter? And this is, of course, where genetics comes in as a very powerful tool. You can start tracing the ancestry of Aboriginal Australians. You can actually find out when did they diversify from other living people, when did they come out of Africa. We can link biologically these individuals to other human beings in space and time.
Analyzing the DNA was like looking into the deep past, back to the first wave of humans migrating out of Africa. Rather than exploring Asia, the first Australians headed south. They split from the rest of humanity 60 to 70,000 years ago. And then they were on their own.
Aboriginal Australians are descending from the first people moving out of Africa and getting into Australia. They are direct descendants of the first modern human explorers.
These explorers must have reached the southern tip of Asia. Instead of turning back, they adapted to life at the coast. Hugh Barton is an archaeologist and an expert on the lives of coastal hunter-gatherers.
Coastal environments like this with, sort of water, lagoons, sort of back swamps, potentially mud flats, mangroves, they're really good places for food for hunter-gatherers. There's, you got shellfish, fish, clams, eggs, worms and grubs. There's lots of rich, high-energy foods that people can take from these environments. But if you've got a group of, say, 5 to 10 people, you might clean out an area of its sort of high-rank, good quality resources, within days or weeks. So that can be a real trigger point for people deciding then, well, we need now to move on to a new location.
For hunter-gatherers living at the coast, relocating could mean a trip offshore.
Perhaps you can see small islands, not too far away. So people will go out ahead, they'll find out, they'll come back, they'll communicate to the group information about what they found, and they might make then a decision as a group to go on to potentially, and maybe hop across to another island.
Once people started island hopping, Barton thinks it was only a matter of time before they stumbled on a way to reach Australia.
Most of us look at the ocean now, kind of see that as a real barrier, and it's kind of to be avoided. You want to be on the land because that's okay, that's solid, But if you've got a group of people that maybe they've got some simple watercraft, they're out, they're fishing, once they've gone out, who knows, maybe they were brave enough to go out overnight. But then suddenly they start to pick up signs that might tell them that potentially there's a landmass out there. Could be clouds, could be birds, could be driftwood. They might think, actually maybe it's worth kind of pushing on a bit here. Maybe for 20 years, 100 years, they don't really get there. But at some point, someone goes that little bit further, just takes that further risk, whatever the circumstances, gets across. The next thing you know, they're bumping up against the coast of Australia. it becomes feasible. You can conceptualize how that voyage, that journey might have happened.
Today, this would be a 350-mile journey. But in prehistoric times, the coastlines were very different. "60,000 years ago, the planet was in an ice age. As great ice sheets were spreading across the northern hemisphere, so much of the world's water was frozen, sea levels had fallen by 400 feet. The gap between Southeast Asia and Australia had shrunk. When people made the crossing, the two continents may have been as little as 60 miles apart. No one knows how many people first arrived in Australia. It may have been dozens, hundreds, perhaps 1,000. But according to the genetics, there was just a single wave of migration, which then stopped.
It seems like there's one entrance to Australia, and then people are, so to speak, spreading across the continent, occupying the continent. And this, as far as we can see, that only happens once.
Around 55,000 years ago, humans began exploring Australia. 40,000 years before they reached North America. Here they were truly alone, cut off from the rest of the world, in a virgin continent.
But these early Africans did not just stop at populating Australia, Melanesia, and Southeast Asia. They would also go on to populate the Americas as well, over 50,000 years ago.
All right, and with that, we're gonna end this one, and then the next video presentation will naturally be the migration to the Americas. All right, let's stop it here. So my final thoughts on these migrations that occurred in Asia and the Pacific Islands, I really think is all interesting. The information that Above the Clouds presented, that was so thorough. I'm talking about airtight defenses, statements. It's not based on conjecture. He has so many facts, DNA evidence, skeletal remains, all of these types of things here. It can be overwhelming, but you guys are sharp, savvy. You know how to separate things and compartmentalize this fact, and then come back to this one. Or you just know how to put things in chronological order. So I'm really not worried about you, the viewer, who's taking in this information here. Now, to use the slide as my guide here, we go over the migrations through the Near East across to India to Sundaland, and he provides proof in the form of interesting peer-reviewed articles that details the genetic evidence. And one thing I like and really appreciate, and I know that the audience will too, is the topic of S&Ps and how to understand it and the relevance to this topic that S&Ps have. You know, you got to know who's who genetically, man. So the emergence of pale skin in Asia and in Europe is something that is a very important point, something that's very, very useful in this topic here. Now, I like the divergence of time when it comes to these populations. For example, out of Africa to the Near East, then a group breaking off from the Near East to Asia, Europe, then that group from Asia to the Pacific Islands or Sundaland, and then from that area, Sundaland, to the Americas. I will provide a separate video detailing more in depth the idea of divergence of time and just give some better examples and help people to come to the logical, proper conclusion, in my opinion, because there's a lot of confusion when it comes to this topic here. And we have more skeletal remains and genetic evidence in regards to the Orang Asli, or original people, that we can speak of here. We have an abundance or surplus of information that we can use to combat that harmful, long-held narrative that somehow binds melanated people to mediocrity and negativity. But in reality, we are the spark. You know, this is for us, man. It's about us, you know. So we got so much proof and validation that we can just use, and we can create too. We're creative people worldwide. Doesn't matter if you're in the Americas, it doesn't matter if you're in Europe, Africa, Asia, Sundaland, aka Australia, the Pacific Islands. It's about us, man. So let's go ahead and use this information here, and that will really conclude everything. The next video presentation will be all about the Paleo Americas, the early people to come into and populate the Americas, the Orang Asli people of the Americas. To reiterate, back to back to back. And yes, they were melanated people. And also, I will put his presentation in my description so you guys can go back and look at the full presentation, his full work without my input. All right, take care.